Okay, here we have the fourth video in trigonometry. This time we're looking at solving right-angled triangles. In the first example, we have a triangle given here, and we're to find the sides x and y to one decimal place. Now let's label our sides. Compared to 35 degrees, we have y is the opposite, x is adjacent. We're going to write out our rules. So katoa, there's the three formulas, and always find the x one first. Whichever is first you'll find first. So we see we have x relates to, we have the hypotenuse is 12 and x is the adjacent. So which has adjacent hypotenuse? And we see that it's cos. My statement is that cos 35 degrees is equal to x over 12. So if we multiply both sides by 12, we then see that x is equal to 12 cos 35 degrees. And this is what we type into the calculator. And it says to one decimal place. When we type it in to one decimal place, that's 9.8. And we see, just compared to the 12, you see it is a bit smaller than 12. It's the size of it sounds about right. It makes sense with our answer. And now we're to find the y value. So we're interested this time maybe in opposite and hypotenuse, since the hypotenuse was the one that was given us first. So sine 35 degrees is y over 12. So multiplying both sides by 12, y is equal to 12 sine 35 degrees. I can put this into the calculator. And we see we get 6.9 when we do. Okay, in the second question, we're to find an angle. It's the angle ACB, the size of the angle ACB. It's shaded in purple here. Let me just give it a single letter name. I'm going to call it C, just to make it easier for this question. We label our sides that we're interested in. The 9 would be opposite to C, and 13 is adjacent. We're not that interested in hypotenuse in this question. I'll just label it anyway. We write down our three formulas, so katoa. And I see this time we're interested in the opposite and the adjacent. So which has opposite and adjacent in it? And we see it's tan. So my statement is that tan C is equal to opposite, which is 9 over adjacent over 13. So we're finding the angle, we use the inverse. C is tan inverse 9 over 13. We always use inverse when we're finding an angle. So we type this exactly like that into the calculator, and to the nearest degree is 35 degrees. Make sure the calculator is in degrees. Okay, example 3. Now this, again, it just looks more muddled. There's maybe 3 triangles in the picture here. It first asks us to find x, and we see x is part of this small triangle where we know the angle 62 and the side 8. So compared to 62, x is opposite 62. We'll write down our rules, so katoa. This time we're interested in the opposite and adjacent. So my formula will be the tan formula. So my statement is tan of the angle 62 is opposite, which is x over adjacent over 8. So if we multiply both sides by 8, then I have x is equal to 8 tan 62. And put that into the calculator. We see the answer is 15. And we just write 15 here. Now we're looking at the second question. We're going to look at to find y, we'd look at the triangle on the right hand side here. Compared to 37, 15, the answer we have is opposite and y is adjacent. So we're again going to use tan. The statement is that tan 35 is opposite, which is 15, over adjacent, which is y. Now we do a swap around here. We multiply both sides by y and divide both sides by tan 37, and it's as if y and tan 37 would change places. Let's do it in 2 steps. So multiply both things by y, and now I divide by tan 37. So y is 15 over tan 37 degrees. I just type this into the calculator. And again, it's to the nearest whole number, and we see it's closer to 20. Okay, example 4. Okay, a little bit like the last one, this one here. So in this triangle, we first try to find what CD is. That's the length of this line here. Let's call it X, just to give it a single name. And we see that it's opposite to 35 and adjacent to the 6. So looking at the small triangle, we'll write down our rules, so katoa. And we're interested in opposite and adjacent. So it's tan, that's what we'll use. My statement will be tan of 35 degrees is opposite, which is X, over adjacent, which is 6. Therefore X must be equal to 6 tan 35, multiplying both sides by 6. And type this into the calculator. And it says to one decimal place it will be 4.2, and I see it's in centimeters, so we could write centimeters there. We want it at this stage. Okay, looking at the second question, it's asking to find this angle at B. Now I'm going to maybe give it a single name. I'm going to call it B just to give it a name. Now we have our opposite. Now we worked out already this is 4.2, and we have the adjacent side, which is 9. So again, we're into opposite and adjacent, which is the tan angle. So my statement is that tan of the angle B is opposite, which is 4.2, divided by the adjacent, which is 9. Therefore B is equal to tan inverse 4.2 over 9. We always use inverse function when we're finding an angle. And type this into the calculator. Now we see the answer is 25 degrees.